In this example, we want to show that f of x is continuous at x equals 1. And then we want to determine whether it's differentiable at x equals 1. So first, to show that it's continuous, I must check using our 3 rules for continuity. So first, f of 1 is equal to 1 squared plus 1 plus 1, which equals 3. So f of 1 exists. The second step is to check the left and right limits. The limit as x approaches 1 from the left would use this function of x squared plus x plus 1. I can just do direct substitution here. That approaches 3. The limit as x approaches 1 from the right, we'll be using this function, 3x, using direct substitution. That's also 3. Therefore, the limit as x approaches 1 of f of x equals 3. And so the third step is making sure that f of 1 equals the limit as x approaches 1 of f of x, which equals 3. Therefore, f of x is continuous at x equals 1. So if we were not preparing for the AP exam, we would not have to do all of these steps. We could probably just visualize this graph and see that it's continuous. But for my assessments preparing for the AP exam, this is how you check for continuity. So now that we know it's continuous at 1, let's check to see if it's differentiable. So it's differentiable at x equals 1 if the limit as x approaches 1 of f prime of x equals some number. So that means the slope on both sides of 1 has to be the same. So f prime of x, using power rule, the top piece becomes 2x plus 1, and the bottom piece becomes 3. So therefore, f prime of 1 equals 2 times 1 plus 1, which is 3, or 3, which implies that f prime of 1 is 3. So therefore, the function is differentiable at x equals 1, and we know that f prime of 1 equals 3. So let me try to fit a quick little sketch of this here. So we know at 1, they're both going through 3. And then we can see the slope of this line is going to be up 3 over 1. So it needs to gradually push through this quadratic, showing that the slope from this side and the slope from this side are approaching the same slope of 3. So we must check continuity in this formal way of these 3 steps, and then check differentiability by checking both sides of the limit of the derivative to be the same.